Hello. Okay, looks like my mic's working. So this session is going to be introduction to our equation, our graphing sort of unit. So today we'll be starting with linear equations and graphing linear equations. So we'll learn a lot of the basics about graphing, and then we'll get into some more specifics. So I'm going to try and use the PowerPoint today. Hopefully it works with my pen, so if not, then we'll have to go different routes. So let's share the screen here. Okay. So let's hope for the best. So as I said, we're going to start with linear equations. So we're going to talk about what is a linear equation. We're going to just start with talking about quadrants and the way quadrants are laid out in an XY graph, as well as how to just plot a point on a graph, because that's a pretty important thing to know before we get into graphing. So when we're talking quadrants, it's a little bit different than you would expect a quadrant to be laid out, and we use the quadrant because quad means 4. So there's 4 sections in an XY, so a two-dimensional graph. So on our graph we have, just a minute here, sorry, my pen tool's upside down. Let's try this. Oh, okay. So we have our x-axis, which is here. So this goes along this part of the graph. So that's our x-axis. And then our y-axis is this way. And I always remembered it from high school with the y, the tail is going down in that vertical way, right? So my y-axis, so it stretches down. That's how I always remembered it, but whatever works for you. And when we label our quadrants of this graph, our first quadrant starts in this section. So the reason for it is because this is my positive x and my positive y axis. Then you would think maybe we would go clockwise, so it would be 1, 2, 3, 4, but it's the opposite. We're going to go from 1 to 2 to 3 to 4. So this is how it's labeled. There's certainly questions like this on your assignment questions, as well as I believe your unit tests. So let's look at this first. So when we're plotting points, my points are laid out like this. So I have my x coordinate and my y coordinate. So we call it coordinates, just like if you were doing Battleship, right? If you haven't played that, then that's not a very good reference. But this is my x and this is my y value. So this is my x-axis. So I have 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going up this way, 1, 2, 3, 4, 5, 6, 7, 8. And then in this direction, I have my negative values. So I have -1, 2, 3, 4, 5, 6, and so on. And then the same thing here. You can't see it, but this would be -2, -4, -6, and -8. So for my first point, I have an x value of 2, so that's where my x is 2, and a y value of +4. So this is my 2. I'm going to go up to a positive y value of 4, and that's going to be my point. So we usually label in this situation my actual point. So I'm going to put the coordinate above it. So that is my point for 2 and 4. Now for the second one here, we still have x and y. The order never changes. So my x is now -3. So 1, 2, 3, so that's -3, and my y value is a +5, so I'm going to go all the way up to +5. So this lands in my second quadrant, and it would be -3 and 5. So to backtrack here, this is quadrant 1, this is quadrant 2, and that's where my point lies, -3 and 5. Now for the third one here, we have a -4, so my y value is -4, which is here, and a -2, and I apologize, this is right in the way, but this is about where it would be if that wasn't in the way. But -4 and -2 land in the third quadrant. So some questions ask you to draw the points, and then some just ask you which quadrant is the point in. And apologize, there's no bracket here. So then the next one, my x is 3, so I'm here, and my y is -5. Oops, I just realized I did this backwards. Well, that's a good example of doing things wrong. My x should have been -4, not my y. So let's go back here. That one was done incorrectly. Okay, sorry, my x is -4, so -4 is here, and my y is -2. So this should have been -4, -2, like that. X is -4. Okay, so back to the third one. My y is 3, and my x is 3, +3, and my y is -5. So I have +3, -5. So that's going to be 3, -5. And that tells me that this is in quadrant 4. Okay, so that's the basics of quadrants and just plotting points. That's a pretty important thing to know because we're going to have to plot several points in order to graph linear equations. So just a bit of vocabulary here. So anything that looks like this, that has our x's and our y's, our variables, we call an equation. And in this case, we call this a linear equation. So I'm just going to move this out of my way here. So we plot or draw a graph on a grid. So this is our what you might refer to as graph paper. So we draw our graphs on a grid. The line represents all the values where the equation is true. So this is just all the points. So there's a bunch of points on this graph. There's infinite amount of points. And all of these points, all of these values is where the equation is true. So it satisfies it. We'll get into that a little bit more after this lesson, but basic things you need to know is this is my line. It's called a linear equation, or the line's called linear because it's a straight line. So that means that we have a constant rate of change. So we'll talk a bit about that when we get to slopes, but basically it just means a straight line. Again, my x-axis is this way. So this is my x and this is my y-axis. And then my origin is 0, 0. So that just means the origin of where my x and y intercept. We don't really use that one too much. This is a point on the graph. And line segment. So this means usually in math or in graphing, we're going to put arrows on the end because this tells the reader that the graph goes on infinitely, or it goes on past certainly what we've been able to graph. So just some basic vocabulary. One method to draw a straight line is to substitute values into for x and y into an equation. We call this the table of values. And when we're creating a table of values, the typical intro to this, we pick our points -2, -1, 0, 1, and 2. The reason for this is on my x-axis, right? So this is my x-axis down here. I have, if I'm going to pick -2 and -1, I'm picking I'm picking points on this half of the line, and then I'm also picking 1 and 2 on this line, and then I'm picking 0. So this is our typical table of values, but you could pick any value for x because we just talked about the fact that this is an infinite equation or an infinite value. So you could pick any point. The problem is the bigger the number for x is, the further it is on this part of the graph, right? So if you picked like -400, it's way over here and you'd need a very large piece of graph paper, or you need to change the scale at which you increase your x's. So you could put this as like maybe 5, 10, 15, 20. But typically, also, if you pick those higher values, it's harder to calculate, and you'll see in a bit how we actually calculate our y values. So we typically just try to keep smaller numbers if possible, and we'll look at one more method in a minute here. So first example, draw the graph of y equals x plus 2. So we start with our table of values, -2, -1, 0, 1, and 2. Actually, I believe I have it typed in here. Okay, you know what? Sorry, I'm going to erase that because I just remembered that I have it all typed out. Okay, so the first thing is we express the equation as a function machine. This just basically means that you're going to put a value in, and this function machine is going to spit out a different number or a different value. So this is my equation, y equals x plus 2. So if I put in a value, right, for x, it's going to add 2 to whatever that is I choose for x. So whatever number I choose to be x, it's going to add 2, and that will give me my y. That spits out my y. So we start by just completing a table of values. In this example, I started at -3 and went all the way to +3. You don't need to do this many values. Actually, we'll see it in a minute. You only actually need 2 points to graph a straight line. But for the sake of practice and for the sake of getting to learn this, we're going to pick a few more. So I've picked my x to be 3, -3. So how do I figure out what y is going to be? Well, this was my equation. And what I'm saying is I'm letting x, so this is x, be -3. Or in other words, I'm taking whatever number it is and adding 2. But if you want to sub it into the equation like this, some students prefer that. -3 plus 2 gives me -1. So I get a -1 in that spot. We can do the same with 2. -2 plus 2 is going to give me 0. So 0 goes in that spot. Then we're going to put a -1 in for x, right? So we're going to do this value next. Plus 2 gives me a +1. And then for 0, we get 0 plus 2, which gives me 2. And then for 1, we'd get 3, for 2, we'd get 4, and for 3, we'd get 5, right? We're just adding 2 each time. So we're just subbing it into this equation, and it's spitting out our y value. So what it's giving me, these are coordinates, okay? So another way to express it, I'm just going to erase this here. Okay. So this point here, I think I have it. We're going to plot each pair of values as coordinates. So this -3 and 1 is a coordinate. So it's a coordinate of my x being -3 and -1, just like we did in that last example. So this is my x value and this is my y value. So I'm going to go to my graph and I'm going to look at x equaling -3 and y equal -1, and it's going to start there. So that's going to be that point. Then we'll look at -2 and 0. So x is -2, y is 0. So that's going to be around there, right? Because it's just the same thing. It's -2 and 0. So my x value is -2 and my y is 0. So I'm going to plot that point there. Then I'm going to do the same thing for the next one. So I have -1 and 1. So this is x equals -1 and 1. Then I'm going to go to 0 and 2, which is going to be here, right? And then I'm going to go to 1 and 3, 2 and 4, and 3 and 5, and those are all my points. So if I was doing this on graph paper, I'm just going to take a ruler or anything straight, and you don't even really have to, but I'm going to draw a line through all of these points to make a line, and that creates my linear equation using, so all we did, we started with this, right? We started with y equals x plus 2 as our equation, and what we did is we just picked any value we wanted. We decided to use -3 all the way to 3 on the number line, and that gave us the equation of the line. So we were able to use that to draw the equation of the line. And usually we always try to label our line. So we always try to put y equals x plus 2, so the equation of our line on the line. Let's see here. Frozen. Oh, there we go. Okay, new graph. So now we're going to draw the graph of y equals x minus 3. So we're going to express it as a function machine. So anything we pick for x, we're just going to subtract 3 from it, and it becomes y. So we'll start with our table of values. We're going to pick the same one. I'm fine if you just do -2, -1, 0, 1, and 2. You don't have to do all of these, but again, it's just for practice. So for x equaling -3, so this is my equation now. And the last one we added 2, now we're subtracting 3. So I have, for x, I'm letting it be -3 first. So I'm going to put -3 in for x, minus 3, and that gives me -6. Now I can do the same thing for -2. So I have -2 in for x this time, minus 3, right? Because my x is in this spot. So I get -5. Then I can put -1. So I have -1 minus 3. So I get -4. And again, if you're not super great with your sign numbers, you can always use that negative button on your calculator. And then 0 take away 3 is -3. 1 take away 3 is -2. So maybe let's try that one. So for 1, I have a 1 in for x, minus 3, and that's going to give me a -2. And then 2 is going to be 2 take away 3. That gives me, oops, a -1. And then for 3, I get 0. So that's great. Now, how do I plot these numbers? Same thing, right? Now we're looking at coordinates. So for the first one, so we're going to plot each pair. -3 is here on my x-axis. I'm going to go all the way down to -6, and it's going to put me there. that's my first value. Then for the next one, we're going to do -2 and -5. So at -2, I'm down at -5. So that's going to be right around there. Then I'm going to do -1. So this is -1 and -4. Now, just pause here for a minute. If you're doing these and you find, so let's say accidentally you mix this up and you accidentally did -1 and -4, so you accidentally plotted it backwards over here. You're going to ask yourself, does that make sense if I know this has to be a straight line? So if this should be a straight line, does it make sense that my line's going to go like that? No. So you kind of go back and ask yourself, oops, what did I do wrong, right? So you do want to, in the end up with a straight line. So if you're not ending up with a straight line, then go back and check your work. So it could have been that you did a calculation wrong here in this section, or you just accidentally plotted it wrong. Both of those things happen a lot. So then I have 0 and -3, so that's here. So x is 0, y is -3, 1 and -2, 2 and -1, and then 3 and 0. So then your next step is to join the points and make a straight line, and then write your equation on the line. So that's the equation for y equals x minus 3. So let's try one where we don't have anything being added or subtracted, but it's actually being multiplied. So my equation now is y equals 2x, expressed it as a function machine. You don't have to do this step, it's just to get you used to it. So whatever my value for x is, I'm going to multiply it by 2, and that's going to spit out y. So we're going to start with our table of values just like we did. And I like to write it out in an equation just to teach the students, but you can just take whatever -3 is, times it by 2. Boom, that gives you -6, right? But if you want to look at it in an equation, you're going to do 2 times -3 gives you -6. Then we're going to get 2, because it's 2x, right? Y equals 2x. So 2 times -2 gives me -4. Then I'm going to get 2 times -1 gives me -2, and so on. So everything's multiplied by 2. So -4, -2, 0 times 2 is just going to be 0. 1 times 2 gives me 2. 2 times 2 gives me 4, and then 6. So now we're going to plot these just the same. So we're going to plot each value as coordinates. So we're going to go to x equals -3, -6. It's going to put me there. Then we're going to go to -2 here and -4 down here. And that looks good because we're starting to get a straight line. Then we'll go to -1, -2, 0, 0 is right here. Okay, so when 0, 0, that's your, I'm wanting to call it a vertex, but it's where the x and the y meet. So this is your coordinate of 0, 0, your origin. And then we have 1 and 2, 2 and 4, and 3 and 6. So way more points than you need to graph this line. But then you're going to join the points, make your line, and write your equation of a line. Typically, I like to see arrows on both ends because, again, that tells the reader or the person or whoever that this line goes on forever. It's an infinite linear function. Okay, so this question has a couple things happening. It has a x being multiplied by 2 and being 1. So if we express this as a function machine, we take our x, we multiply it by 2 first, then we add 1. So you can think of it just this way. You're going to start with your table of values, and you can think of it as, okay, -3 times 2 is -6 plus 1 is -5. What I like to do is write it out using my equation. So 2, my x is -3, right? Because I'm picking -3 first, plus 1. 2 times a -3 gives me -6, plus 1 gives me a -5. And then we can do the same thing for 2. So we have -2 plus 1. So that gives me -4 plus 1 gives me a -3. So -3. And then 2 times -1 is -2 plus 1 is a -1. 0 times 2 is 0 plus 1 is 1. 1 times 2 is 2 plus 1 is 3. Then we have 5 and 7. So all we did was sub these values we picked into our equation of a line. Once we've done that, we just have to plot the coordinates. So for x equals -3 and y equals -5, it's right there. So just jump here. There, -2, -3 is going to be right there. -1 and 1, 0 and 1. So x is 0, y is up 1, 1 and 3, 2 and 5, and 3 and 7 is off the graph. So we could graph it on a bigger piece of graph paper, but in this case it's off the graph, but that's okay. We have more than enough points to give me that equation of the line, or sorry, that drawing of my line. And then I write my equation. So with this one, we had to multiply by 2 and add 1. So we've kind of combined a couple steps to this equation. So do it step by step. Do your multiplication step first, then your addition or subtraction. So let's look at the same thing here. Here we have to multiply our x value by 3, then subtract 4. So we're going to complete our table of values. And if you're like me, you can write your equation down. So we have 3x minus 4. This just leaves less room for error, I find. So we're going to start with x equals negative 3. 3 times negative 3 gives me negative 9 minus 4. So that gives me negative 13. And we'll do the same thing for, negative 2. So we have 3 times negative 2 minus 4. That gives me negative 6 minus 4 is negative 10. Sorry, that's a 10, not a 16. They got 12. That's not right. How did I get 12 there? 3, what did I do wrong? 3 times negative 2 is negative 6. No, I think that might have just been an accident. This should be a negative 10. Let's try the negative 1 to verify. So 3 times negative 1 minus 4 is negative 3 minus 4. That one is negative 7, so that's right. 0 will be negative 4, and then 3 times 1 is 3 minus 4 is negative 1. Okay, those look good. So we'll start with 0 and 4 for some reason. Why did I do that? Okay, 0 and negative 4, so that goes there. 1 and negative 1 goes there. 2 and 2. Oh, because those are way off the graph. That's why I had to do that. Okay, yes. 3 and negative 13 are way off the graph. And so this should have been a 10 though. So I was going to use this actually as an example to see that you wouldn't have had a linear equation. Also, the other thing is you'll notice that these actually change by the same value. So this changes by 3. This is 3. This is 3, right? It's going up 3. In this case, it's adding 3 each time because it's going from 13 to 10. 3, 3, and 3. So we also know that if we have the same value of increased, right, it should make sense because it's a linear function. So each thing should have the same rate of change. So that's also a giveaway as well, but that was just an error. So we're going to plot the points that we can on the graph. So in this case, I had to start on this point, but that's okay. Graph our equation, or draw our line, join the points, and write our equation of a line. Okay, so this example I wanted to show, I'm hoping this is the example, I'm trying to remember, but we're going to just complete the table of values. So we have x here plus 4. So if my x was negative 3 plus 4 gives me a 1, 2, 3, 4, 5, 6, 7. So then I'd plot that graph. Oh, what I wanted to say is here, I think in a couple slides, I start to make the point that we don't really need this many points to graph this line. We could have easily just picked these 2 points, right, if we wanted to, or any 2 points really that we felt like it. But these, I think I just have more examples. So 2x plus 1. I'm just going to skip over these. I feel like we've done quite a bit. Oh, this one's a good one. Let's do this one because we have a fraction. So y equals 1/2 x plus 2. So same thing we've done here. The x, so whatever you pick, it's going to be multiplied by 1/2 and then add 2. But let's write it down. So we have 1/2 x plus 2. So let's do it for 3. So if x is, 1/2. Okay, 1/2 times 3 is going to give me 3/2 plus 2, which is going to give me, oh, sorry, it's glitching. Oh, sorry, -3, my bad. So -3/2 plus 2. So if you're not able to do this in your head, which I'm not, you'd have to find your common denominator, but you could use your calculator. So you're going to go to your calculator and do -3/2, right? Plus 2. Let's see if I can share. I'm just gonna see if I can share my calculator because I know sometimes we forget how to use that. So let's see how easy that'll be. Share. Okay. So we had 1/2 times -3, which gave me 1.5 or 3/2, right? And we added 2, I think. Yeah, we added 2, and that gives me 1/2 or 0.5. So that's how so you could have done the math like I did, or you could have just went 1/2 times -3, which was our first step, equals add 2 to that, and that gives me 1/2. So let's go back to our PowerPoint. Uh-oh, what happened? Oh, okay, there we go. Okay, so -3/2 plus 2 gives me 1/2 or 0.5. It could also be written as, I like decimals better because sometimes you won't get these really nice even numbers or decimals, and that's okay. But 0.5 I know how to graph easier than something else, right? So I have them all calculated here, but let's try another one. We have, oops, 1/2 x plus 2. So now we're going to put in a -2, so you can use your calculator again, but that's going to give you -2/2, which is -1 plus 2, which gives you 1. But again, you could punch it into your calculator right from this step, and it will give you that 1. And then you can do the same thing for -1, which will give you -1/2 plus 2, which gives you 1.5, and so on. So these are all just using your calculators. Now to plot this, I have a -3 and a 0.5. So at x equals -3, I'm going down to 0.5. So it's going to be kind of in between. Oops, I lied. That's -0.5. Sorry. Okay. -3, positive 0.5. So that's going to be up here. So that's going to be my first point. And then at -2, I'm at 1. At -1, I'm at 1.5. So that's between 1 and 2. And then 0, I'm at 2. 1, I'm at 2.5. So between 2 and 3. And then at 2, I'm at 3. And then I can draw my straight line and write my equation. So fractions are no different. You just might want to bust out that calculator if you have to, and that's okay. So with this one, what I've done is I've flipped it around. So I still have my function, my equation of a line. It's linear. And I have 2 take away 2x. So I'm going to do the same thing here. Right, this is my equation. So for the first one, my x is -3. So wherever my x was, I'm going to sub in a -3. So -2 times -3 is going to give me +6. So that's going to give me a +8. And then I'm going to do the same thing for -2. So that gives me 2 plus 4, which gives me 6. And then so on. So I'm going to keep calculating all of these. These are all the values I've got. I could honestly stop here and graph these 2 points and I have an equation of a line. Some of the questions ask you to make a table of values using certain points just to make sure you're getting practice, but we'll talk about in a minute what 2 points are the easiest to choose when graphing. So now you can see my line looks a little different. It's going down, right? It's going, most of the ones I've graphed are positive slopes, in other words, so they're going up this way. In this case, it's going down this way, and we'll talk about what that means. But we're going to start with our first one, which is -3 and 8. That's off the graph. So we'll bump to -2 and 6, which is here, -1 and 4, which is here, 0 and 2, and so on. And then we just draw our line the same way and write our equation of the line at the top or the bottom or wherever you want, somewhere on the graph. So this is finally where I bring it up. For some reason, I thought it was sooner. You only need 2 points to graph a straight line. Why bother with the rest? Do you agree? I think most of my students would agree because it's much easier to just graph 2 points than, the last ones we've been doing are a lot more points, right? So sometimes we're doing 4, sometimes we're doing 6. In any case, 2 is usually the easiest to do. So in this example, the 2 points that were picked were 0 and -2 for my x's, and I subbed in to get my y of 3 and -1. So you really only need 2 points to graph a straight line. The ones that I like to use are what we call our x-intercept and our y-intercept. And we will talk more about this as we get into writing the equations of a line. But an x-intercept just means if I have a graph, actually, can we go back a couple slides? So let's go back to this slide. My x-intercept means the point at which my graph intercepts my x-axis, and my y-intercept is the point at which my graph intercepts my y-intercept. So that's what it means. But in substituting, so I'm going to erase that because it's just going to get confusing. When we substitute this in, all it means is if I want to find my x-intercept, I substitute 0 for y. So for x-intercept, let y equal 0. For y-intercept, we do the opposite. We let x equal 0. So whatever my equation is, so in this equation, it looks very different, and we will talk more about this as we go. But in this equation, it's not our, I think we call it a standard form equation. It's not our linear equation or our slope-intercept form. I think it's called standard form. But in any case, it's not as easy to sub in, and maybe I don't want to do like 6 calculations. So for my x-intercept, I'm going to let y equal 0. So the y was here. So wherever there's a y, I'm putting 0 in. This becomes a 0, right? So I'm left with 2x equals 6, and to solve for x, I divide both sides by 2, so x equals 3. So that means my x is 3, right? Because I let my x equals 3, and I let my y equals 0 in this case. So instead of subbing all of my x values in, I did something different. I let my y equal 0 and subbed it into the formula, and then over here, I let my x equal 0. So I had a 0 here, so that becomes a 0. I get 3y equals 6, y equals 2, and I'm done. So I get 0 and 2. So those are my 2 points, and I could graph using these two. So it looks something like this. So the first one, 3 and 0, and then 0 and 2. So that's what my equation looks like. That's a rough sketch. Okay, so for this one, I wanted to just quickly practice finding the x and y intercept for each of the equations. So these look different than what we're used to, right? So this is x minus y, so it's not y equals 5 plus x or anything like that, right? But that's okay. So for my x-intercept, I let y equal 0, and for my y-intercept, I let x equal 0. So if I let y equal 0, I get x take away 0 equals 5. So x equals 5. So my first coordinate is 5 because x comes first in my pattern, right? And 0. In this case, I have my x equaling 0. So I have 0 take away y equals 5. So negative y equals 5. Let's get rid of that negative in front of the y. We don't like it. So y is equal to negative 5. So my other coordinate is 0 and negative 5. So if I wanted to graph it, we're just going to do a rough sketch, okay? So first one, 5 is around here. Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4. 4, 1, 2, 3, 4, 5. So this is my x and my y value. So at x is 5, I'm at 0. 1, 2, 3, 4. And then at 0, x is 0, I'm at negative 5. So my line, sorry, that's a terrible drawing, looks like this. It's really hard to do on this. So that would be x minus y equals 5. So all I did was my x-intercept and my y-intercept. So we can do the same thing down here. So let's let y equal 0. So I get 2x plus 3 times 0 equals 12. That goes away. So I get 2x equals 12. Divide both sides by 2 to get rid of that 2. X is equal to 6. So that just goes back to our algebra. So 2x equals 12. To get rid of the 2 in front of the x, I divide out that 2, and 12 divided by 2 is 6. So now we can do the same thing for the, that means our coordinate is 6 and 0. And then over here, I have 2 times 0 plus 3y equals 12. That goes away. So I get 3y equals 12. Get that y by itself, divide both sides by 3. So y is equal to 4. So now I have a coordinate of 0 and 4. So that looks like 6 and 0, so around here, 0 and 4, so around here. So it's going to look like something like that. And let's do this one as well here. So we have something a little different, but that's okay. So the first one, we're letting y equal 0. So we have 4x equals 12 plus 3 times 0. That goes away. So we get 4x equals 12. Divide by 4. Right, that goes away. X is equal to 3. Now we're going to do the same over here, but we're going to let, what did I do? Oh no, yeah, we're going to let x equal 0. Sorry, I thought I messed it up. So we have 4 times 0 equals 12 plus 3y. So now we're left with 0 equals 12 plus 3y. Let's bring the 12 over here. So in order to do that, it has to become a negative 12, right? Because it was a positive over here. Divide this side by 3, divide this side by 3. So I get negative 4 is equal to y. So this is another way, oh, sorry, that means that it's 0 and negative 4, and this one is 3 and 0. So this is another way that we can calculate, just putting in a 0 for y and a 0 for x, and that gives us our 2 points on our graph, and we can graph that linear equation. So let's go and graph this one. So we have 3 and 0, and 0 and negative 4, so around there. So this is our graph. Yeah, so if the equation looks a little wonky like these ones, the x-intercept is always a good choice, but you can pick any value. You could have used any, you could have just stuck with your table of values here and subbed in for x and calculated for y. It will still require some algebra. And if you need a refresher on that, then you're welcome to go back to those videos or those booklets, because that algebra is going to follow you through most of your math courses. Certainly this one it has so far. So, okay. So the next thing we're going to move on to is slope. I'm just going to see how we are for time here, how long it's been. Does it tell me that? I feel like we're going close to. I think we will probably leave off there for this this slide or this PowerPoint, because we're going to get into slope, and we're also going to get into calculating our equations using some algebra. So I think slopes will nicely fit in with that. So I'd like to just stop here for today, and then for the next lesson, which will be, if you're in my class, it'll be Wednesday. Otherwise, you know, just skip to the next episode whenever you want, or episode lesson recording, but we'll stop there today. Thanks for listening.